Okay, so turn to page 240. This is example 1. We're trying to graph y equals sine x minus 30 plus 3 and try to understand how this works. We know how to sketch y equals sine x. We can see that the maximum here, the first maximum, is 90, 1. 90 degrees. Make sure you're in degree mode. Now if you write y equals sine x minus 30, you can see that the x value of the maximum got shifted 30 to the right. 90 plus 30 is 120. Think of opposites. This is exactly the same as transformations that we learned previously. Now the y value of 1 moves up because we're adding 3. Let me just change the color here. Let's make this graph blue. And as you can see, when you flash this graph, the blue and the black graph are now the same. The domain is all real numbers, and the range now, you can see, is between 2 and 4. Okay, let's move on to example 2 on page 240. We're trying to sketch this. Y equals negative 2 cosine x plus pi minus 1. We changed everything to radians with appropriate zoom settings. Let's focus on y equals cosine x. We know that cosine starts at 1 and it goes down to negative 1, and the 1 full period is 2 pi. And now what's happening here is we're multiplying the y values by negative 2. So let's go step by step. I'm going to type in y equals negative 2 times cos x. So let's hide this original graph. So focus on the blue graph. This is the original cosine graph. We're going to multiply it by negative 2. As you can see that this initial y value of 1 now becomes negative 2. That's great. Now what we're going to do is we're going to do the shifts next. We always do the stretches and flips first, followed by the translations. So plus pi. Plus pi means pi units to the left. Plus pi. So when we move it pi units to the left, the graph changes. Let's try it on a new line. Y equals cos x plus pi. So if I say plus k, you can add a slider here. You can see that as k is 0, it's the original graph, but as k increases to be some number such as 3.14, which is pi, it slides over half a cycle. So you can see what's happening here. So let's leave it as plus pi. So this is the new result now. It's shifted over. Finally, we're going to take this graph and we're going to move it 1 down, minus 1. So here's the end result. If we show the original graph, which is red, if we hide the purple one, you can see that that was the goal. We transformed it step by step to get this graph here. And the goal is to sketch this over 2 cycles. So let's just sketch this over 2 cycles. Notice how the x value, there's no b value here, the b value is 1. It's not stretched, it's not wider, or it's not skinnier, so the period by default is 2 pi. So to get it over 2 cycles, we could just focus on the positive values. We'll just set up a curly brace here, set up a domain restriction. We'll say 0 is less than x is less than not 2 pi, but 4 pi. So as you can see, this is 2 cycles. You start at the maximum here, you go down the hill, up the hill, that's 1 cycle, down the hill, up the hill, that's 2 cycles. Okay, so we're on example 3 on page 241. This is the goal, to understand how to sketch this, even without a calculator. So start off with your understanding of sine. You know how to sketch sine x. In example 3, we have pi here, we're talking about radians. So in radian mode, we know that sine takes 2 pi to repeat. So why don't we set up the same restriction as before? We could say that 0 is less than x is less than 4 pi. So in the same way, we have this nice restriction, and the goal is to get this new transformed graph over 2 cycles. Okay, let's not worry about this graph, this restriction at this time. So in order to get this graph here, we'll go step by step. We're going to multiply 3 in front of it, so it becomes 3 times taller. Now, a rule of thumb is we should always factor. So 3 times sine, 2 bracket x minus. Now what we want to do is 2 times what becomes 2 pi over 3. It's going to be pi over 3. 2 times negative pi over 3 becomes negative 2 pi over 3. Okay, so we factored out a 2 here because that's the b value. We always remember to factor when transforming. Plus 2. We can see that the green graph is the same as the red now. But because we factored it, we can quickly see what's happening in terms of transformations. So we'll call this, we'll say f of x is equal to sine x. That's the original sine graph. We'll say g of x equals 3 times f of x, which is 3 times as tall. We already took care of that. We'll say h of x is equals to g of 2x, which means twice as skinny. So step by step, we're getting closer to the end result. This 2 means twice as skinny. We're taking care of that. And now finally, we're going to deal with the shifts. We'll say I of x is equals to h of, we'll say x minus pi over 3, which means pi over 3 to the right. So slowly but surely, we're getting towards the final answer here. And finally, we're going to add plus 2. So we're going to say j of x is equals to the previous function, which is I of x, plus 2. So as you can see, this final blue graph, we took a long journey. We achieved the goal of achieving this green graph here. They're the same. This is a bunch of transformations. Always do the stretches and flips first, followed by the translations. So let's just use some language about this graph here. We're going to call this word vertical displacement. If I say y equals 2, the original sine graph had a center line at y equals 0. So we say the vertical displacement is 2 units up. Let's talk about amplitude. The amplitude is the distance between the center line and the top or bottom. So we're at 2 here and we're at 5 here, so we'll say the amplitude is 3. The amplitude happens to be the absolute value of the a value. The period is 2 pi over b. The b value here is 2. 2 pi divided by 2. 2 pi divided by 2 is pi. So this period, in order for this whole maximum to repeat, is going to take half the time as usual, which is only pi radians. The phase shift, we're shifting pi over 3 to the right. That's what's happening. The domain is all real numbers, and the range is between -1, the minimum, all the way to the maximum, which is 5. Okay, so now we're on to example 4 on page 244. Let's try to look at this graph, pretend we don't know the answer. The answer is up here. But what's the equation? What's the equation? So right away, we're going to do the part A, which is all about sine. So y is equals to sine, question mark. We're going to try to get this in terms of sine. Now let's stare at the starting point. I'm going to stare at this point over here. Because normally, if I draw this as my center line, and this happens to be y equals 2, that's the center line, I'm going to actually say this is sine of something plus 2. That's the vertical shift going up. Now what else do we know here? Why don't we talk about the amplitude? The amplitude between the center line and the top, between 2 and 4, is going to be 2. So right away I know it's going to be twice as tall. So the a value is 2. Now let's deal with the b value. We're talking about x. What's the b value? So the b value is not the period, but it's connected to it. This is 1 period. The 1 period is the amount of time it takes to repeat. Now how big is this period? It's going to be pi minus pi over 3. What is pi minus pi over 3, which happens to be the period? This is the same thing as 3 pi over 3 minus pi over 3, which is 2 pi over 3. So this is the one full period of time. So I'm going to say the period, which is 2 pi over 3. So recall the formula. The period is equals to 2 pi over the absolute value of b, which is, we'll just call this b. So looking at the equation, we have the same numerators and we have the same denominators. We see that b is 3. So the b value here is 3, and this graph kind of looks skinnier, so it looks right. Now finally, we know that sine starts in the middle, not at the bottom, but in the middle. It goes up, down, down, up. But you can see that it got shifted. The starting point got shifted to the right a bit. So let's try to figure out how big this shift to the right is. We know that this here is pi over 3, and that this here is just halfway to the right. So half of pi over 3 is going to be pi over 6. This halfway point is pi over 6. That happens to be the starting point right on this line, y equals 2. So we're going to shift pi over 6 to the right. How do we write that? This is going to be, instead of the x, we're going to put a bracket there. It's going to be x minus pi over 6, which means pi over 6 to the right, not to the left. Okay, so now we're going to try to sketch this graph in terms of cosine. We're going to change the word sine to cosine. And as you can see, by simply changing the word sine to cosine, we get the blue graph, which looks similar but not quite the same. Now, there is a connection between sine and cosine. And we're setting x equals pi over 6 because we saw that both these functions got transformed and shifted. The starting point got shifted pi over 6 to the right. Notice how cosine starts from the top and drops down, starting from this red line, whereas sine starts in the middle and goes up. We have to shift this cosine blue graph a little bit to the right, and that little bit happens to be normally pi over 2 units when we're talking about the non-transformed sine and cosine graphs. But because this graph is 3 times skinnier, the pi over 2 divided by 3 now becomes pi over 6 to the right. So a quick way to change it is to transform this cosine graph and move it pi over 6 to the right. So minus pi over 6, and then move it right another pi over 6 would be 2 pi over 6. 2 pi over 6 would be the same thing as pi over 3. So if you could understand that last complicated point, you can very quickly get the cosine graph based off the sine graph. But let's do from scratch. It's a bit easier to understand from scratch. So as you can see, the cosine graph is correct in this manner. We did actually get the same result of this function here, but let's try a different method to see it. Normally, if we say y is equals to cosine x, you can see that the maximum is up here. Let's try to attack the center line. The center line is plus 2. So let's go plus 2. We already knew the period of this graph. We already knew this graph is 3 times as skinny, so let's stick a 3 here. We already knew that the amplitude would be between 2 and 4, which is going to be a 2, so let's stick a 2 up here. And another way of thinking about this is to flip the green graph down. So let's stick a negative sign in front of the 2 and see how that works. So as you can see, this is another way of generating a valid equation which satisfies this graph. Okay, so now we're on to example 5 on page 247, and we're modeling the height of water tide. You can see that it gets shallow here, and the water gets deeper here. And the first question is to graph it for 2 cycles. So this is 1 cycle and 2 cycle, etc. This is even more than 2 cycles. What is the period? So recall that the period is equals to 2 pi divided by the b value, which happens to be pi over 6. So the period is 2 pi times 6 over pi. The pi's cancel. So the period of time for this whole cycle to repeat is 12. Okay, so we actually constrained the domain between 0 and 24 because the period is 12. 2 periods would be 24 hours. And the question in part C is talking about the water depth being at least 13 to be safe. It has to be at least 13. In fact, it's safe up here and it's starting to get unsafe when the water level is very low. Determine the number of hours per cycle the ocean liner can safely dock. Okay, so clicking on the points, we can see that it's safe between here and here, which is between 0 and 2.761. So in terms of one cycle, this here is symmetrical with this up to the halfway point. So we're going to multiply 2.761 by 2, or about 5.52 hours. It's safe for this cycle. If you're talking about both cycles, you can, instead of taking this number and multiplying by 2, you can take this number and multiply by 4 to figure out the total time altogether. But what we have here is 5.52 hours, which is about 5 hours and 30 minutes per cycle. So for this last section in part D, we're given that the minimum water level occurs at 6 hours. And to figure out the next time it occurs at a minimum, you simply add the period. The period happened to be 12. We figured out from the previous part of the question. So 6 plus 12 would be 18. So the time would be 18. In fact, the general solution would be 6 plus, it would be 12n. So n represents an integer, and you'd keep getting the additional cycles as well if you wanted to get that.